something less than 4.5. On number 4, they ask us to find a linear approximation to y equals 2 to the x at the x value 3. And then they ask us to use the tangent line to estimate x equals 2.97. Okay, so to write our linear approximation, what do we need to know?
You need a, I don't remember. You need the derivative. Yeah. And f of a. You need f of a and f prime of a.
Okay. Basically, in order to write a linear approximation, we're writing the tangent line, yes? Which means you need a point and a slope. Okay, that's the, algebra terms I'm going to put it in terms of here. In this case, they say y equals 2 to the x. I'm going to use f of x as my notation here. So, in terms of derivative, what is the derivative of 2 to the x?
Well, technically, it's a calculator problem, right?
Yeah, but I would use the calculator here.
Why not?
I guess.
I mean, is it like natural log 2 times 2 to the x?
It is, and I would go for this part based on that. It is a calculator problem. I don't know, I'm trying to reason this out in my head. The thing is, if you find the derivative, what were you going to do? Find the derivative and plug 3 in all on the calculator?
Mm-hmm.
One thing is, it's going to give you a decimal answer, which is going to make plugging it over here more difficult. So, I would have said the derivative is, which way did we write it? 2 to the x ln2 or ln2 2 to the x?
I write the natural log 2 to the x.
Okay. So natural log 2 to the x is your derivative. That's the rule that we've just got to know at this point in our lives, right?
Yeah.
Or we've got to review before every test. Now, that is your derivative. We need to know what? That derivative evaluated at 3. So at that point, natural log of 2 times 2 to the third.
We don't know natural log 2.
We don't know natural log of 2, but what is 2 to the third?
8.
8. So I could say f prime of 3 is 8 natural log of 2. If you put that in the calculator, you gain some decimal answer, which may or may not be a big issue later. I guess not. I don't know. I'd rather have it exact for right now. And what is this we just found? This is our
Well, to be exact, you can
slope.
enter it in.
If you keep it in the calculator, true. What else do I need? Besides my slope, I need a point.
So it's going to be 8.
So 3, comma, and then 2 to the third is 8. So there is our point, right? So our slope and our point. So let's go ahead and write our linear approximation. I do just have L of x here. I didn't write the actual f of x, so L of x.
What else do you use L of x for? No.
Okay. What do we want to put the slope first?
Sure.
So
8 natural log 2 parentheses x minus 2.9? No.
no.
X minus 3 plus, ending parentheses plus 8.
Doesn't need to be in parentheses the way it is right there. It can just say plus 8. Okay.
No, I said ending parentheses after the 3.
Oh, ending parentheses. I thought you said in parentheses. Okay. So right there. There is our linear approximation. Yes? Okay. Now, officially then it says use the tangent line to estimate 2.97. So 8 natural log of 2 times 2.97 minus 3 plus 8. Without that natural log of 2 here, it wouldn't be bad to do by hand. But with that natural log of 2 in there, it makes it difficult. So that is a plug it in the calculator.
7.83.
What'd you say?
7.83.
Okay, that would be wrong on the AP exam. How many decimal points do we need on the AP exam?
7.834.
So for the moment, I have it written down as, just so I can, 7.83364. Now, in terms of AP exam, you need minimum 3. Okay, minimum 3. Those first 3 are what they're going to grade. So you could either use 7.834 would be the rounded version, or 7.833 would be the truncated version. You could use either of those. Okay. If my understanding is if you leave it with more than 3, they're just going to grade the first 3.
That makes sense. Doc always says up for your response, write anything you know, even if it doesn't, like, even if it's not necessarily correlated to that question, because they're just going to grade what's right. They're not going to grade the extra. Like, if you put extra stuff and it happens to be right, then you'll get it right. But if they put extra stuff, they're going to worry about it. If that makes sense.
Mm-hmm. So what I'm going to say here is that f of 2.97 is approximately equal to L of 2.97, which is the linear approximation, which is the 7.83364. Okay? Okay. Number 5?
Yeah.
Are we good with this one?
Yeah.
What does Eli not like?
Don't know how you got 7.834. Is it just calculator sheet? Is that
The 834 is the if you rounded.
Well, you
I put plus 3.
you put plus 3, but you also, I think you got to end that parenthesis on the natural log.
Do you?
Yeah.
Oh.
He put because it had
Because it automatically pops up.
because
Yeah.
he had 2, but then he didn't put the any parentheses, so that 2.97
That's probably-
minus 3. But then he also put plus 3 at the end too.
I don't
so
know. I am
it's
very,
just-
I'm very tired today.
So who knows? The combination. I'm impressed you got it that close then.
Yeah, it was like 8 point something. Yeah.
Yep.
That works perfectly fine.
Yeah.
Okay.
Okay.
So hitting the right buttons on the calculator at the right time.
That might help.
You know. Okay. 5. Approximate 2.01 to the 5th. Use your calculator to find the accuracy of the approximation and is the linearization an overestimate or underestimate, and explain. So similar to what we just did last time, except going a little farther, if you will. Okay. They want us to approximate 2.015. Well, that's not plugging that into your calculator. That is finding a linearization here. What function would this be based on? If they want us to find 2.01 to the 5th, what is f of x?
Whatever that number is.
Right, but what would the 2.01 be in place of? That's in place of x, right?
Yeah.
So the function we're talking about is f of x equals x to the 5th. Okay, and then we are going to be looking at what is really close to 2.01. Right, we're going to be looking at x equals 2. Okay, that's what we're going to be finding the tangent line for, because 2.01 is very much in the neighborhood of 2. Okay, so yes, f of 2 to the 5th is going to be 32. What else do I need to know? I need a slope, so I need a derivative. What do we know? F prime of x is
F prime of x would be 5x to the 4th.
okay. And if we find, actually, I'm going to go across the page here, I think. What do we need to know? F prime at 2?
80.
Yeah, because 2 to the 4th is 16 times 5 is indeed 80. Okay, so we have a slope of 80, a point of 2 comma 32. So what is my linearization? Or in other words, my tangent line is going to be what?
X equals 80 parentheses x minus 2 plus 32.
Yes? Okay. So that is our linearization. Now, that right there is our tangent, linearization, our tangent line, however you want to say it. They ask us to what? Approximate 2.01 to the 5th. So what? We're going to find L of 2.01. So 80.
Probably end up being underestimated.
Let's see, we're still using, I guess we're still using calculator here, although I could do this one without a calculator, really.
It's gonna be 32.8, right?
Mm-hmm. And that right there is our F of 2.01 is approximately equal to L of 2.01, which gave us the 32.8. Now, we talked, okay, so that's that part. They ask us to find the accuracy of the approximation, which means they want to know the amount of error. Okay. We talked about this yesterday. I think it came up on that very last example, right at the bell type thing. But we also talked about it in the original problem. But in order to get error, you were doing, I figure out where it said, the absolute value of the difference between the exact and your approximation. Okay? So we want to do the absolute value of the exact, so f of 2.01 minus our approximation, so the L of 2.01. Now, this is definitely a calculator thing here, because I don't know what 2.01 to the 5th exactly is. So 2.01 to the 5th appears to be 32.8080401. We found our approximation to be 32.8. So if we subtract these, we're going to be at 0.008, 0.04, so on and so forth. Okay? But remember, how are we expressing error? The absolute value of error is less than or is within. Do you remember what we talked about?
Yeah, this one would be absolute value of error would be less than -1, -2, yeah, -2
So 10 to the negative second, right? Because there are 2 zeros there. Okay. And then our last part was to answer whether or not this is what, under or over?
Underestimate, right?
Why?
I mean, one, you can just go logistically use 2 and instead of 2.01, but also you gotta, I mean, obviously it's absolute value, but you're gonna get a positive one either way rather than a negative, if that makes sense.
Okay. Yeah. If you think about the graph here on this one,
But I mean, yeah, you used 2 instead of 2.01,
Yeah.
so.
x to the 5th. Okay. Well, it really has to do with concave up versus concave down. Our function was x to the 5th. You guys know what x to the 3rd is, yes?
Yeah.
X to the 5th is a similar graph, but just flattened out more at the origin. That's what x to the 5th is. Okay, the higher the power, the more it just flattens out. And so if we're looking over here at 2, well then 2.01 is going to be just a little bit farther there, isn't it? Okay, we can also think of a tangent line. Well, officially, where is our tangent line in relation to this graph? It is technically below it because this piece of the graph here is concave up. And with that being concave up, then that makes our tangent line below it, which makes it an underestimate. Okay? So. So I'm going to say underestimate. I'm going to mention that curve is concave up at x equals 2. Okay? Okay. 6. Find the linear approximation of g of x equals the cube root of x at x equals 8. Use the linear approximation to approximate these values. Compare the approximate values to the exact values. Find the error of your approximation. Okay. So, find the linear approximation. What do we know? We talk about g of 8. G of 8 is what?
2.
Cube root of 8 is 2. Can we talk about g prime of x?
Is going to be x to the 1/3 power, which will just turn into 1/3 x to the negative 2/3, so it's going to be 1/3. And it's the cube root of x squared.
Yeah, you could think that way. Which, and here's the deal. Yes, it doesn't technically say calculator on this one, but we're going to have to talk calculator here a little bit probably. If you don't have a calculator, you need to know that, right? It's the cube root of x squared. So I need to know g prime of 8. I would do the cube root of 8 first, then square it, then multiply by 3. And don't forget to put that
Either
under.
way, you're going to get 4 though, because if you just do the cube root of 64, I mean, it's the same.
Okay. Yeah, true. That is one that we know. We can do the cube root of 64. So 1/12?
Yep.
So now, if we're writing our linear approximation, L of x is
It's gonna be 112 parentheses x minus 8 in the parentheses plus 2.
okay. Just using our modified point slope. Okay. Officially,
Why are we doing two at the same time? We just need to do one.
then ask us to compare.
To the exact values, it didn't say compared to one another.
Well,
It's pointless. Make it two separate problems.
if I start with x equals 10, we're doing f of 10 is going to be approximately equal
What's the cube root of 10?
to L of 10. Well, I'm doing the linear approximation here, which is 1/12 times 10 minus 8. Oops.
Wait, but I said the cube root of 10, not 10. This said find the approximate value of the cube root of 10.
Uh-huh. That's another using the linear approximation.
Yeah, but don't you plug in the cube root of 10 instead of 10? What? Why aren't you plugging in the cube root of 10 there instead of 10?
Because the cube root is the general function. The cube root is a function. We're trying to approximate it at this value here. So what can I compare it to help here? Like on the last one, I didn't plug in 2.01 to the fifth. I plugged in 2.01. Because I had written a linear approximation for x to the fifth. So since I'm trying to find 2.01 to the fifth, I plug in 2.01. Here, I wrote a linear approximation for x cubed. So now, since they want the cube root of 10, I'm plugging in 10. Is that cleared up? Okay. Linear approximation.
Give me 7/6. That's going to turn into 1/6 plus 2. Not 7/6. It's going to be 13/6.
There we go. I was at 2 plus a 6 when you said 7/6, and then my brain fell apart because I was like, wait, what? Okay. If you compare this as a decimal, this is 2.16, and the 6 is repeating, just so you know. Okay. What about for x equals 16?
Or should we compare it to the exact value first?
Oh, I was going to do that at the end.
I'd rather do that before we get started on that one.
So what they want? They wanted the error of our approximations. So what are we going to do for this, the first one that we did?
It's going to be the cube root.
Your original value, so the cube root of 10 minus our linear approximation value, which is at 2.16 repeating. What's the calculator come out to be?
How do you change the value of square root?
Oh, plus. Or not the
Yeah, I agree. It's in the alpha menu somewhere. Alpha F2, yeah.
13/6. So it's going to be 0.012. Absolute value of error
is less than 10 to the negative first.
Okay. And?
What?
Huh? Oh, and the other one.
What?
X equals 16. So we're finding f of 16, which is approximately equal to L of 16, or 1/12 times 16 minus 8 plus 2.
12, so 2/3 plus 2 8/3.
Which for the record is 2.6 repeating. So you can repeat this process for the error, for your error, that is. G of 16 exact minus your approximation at 16. My note said 0.14616.
So error is less. It's
Greater than 10 to the first? Less.
Well, there's how many zeros? There's no zeros, so I would say 10 to the 0. Which, okay,
So that's
what?
just 1. Can't we just say greater than 1?
I'm going to leave it as 10 to the 0 just because that's how we traditionally express error. Okay? And what's the whole point of this? This linear approximation was written for x equals 8. And then what values did we use to estimate? 10 and 16. Are these very close? Not greatly. Okay? The other ones, when we had what? 10 to the negative third or fourth, you know, we've had some better ones that are much closer answers.
It's only off by
It is, but you want to be as specific as possible. So, okay. 7, we ready? On 7, let f be a function that is differentiable for all real numbers. The table below gives the values of f of x and its derivative f prime of x for selected values in the interval -1 to +1. The function is, this is good to note, concave up in this closed interval. Okay? Write an equation of the line tangent to the graph of f of x where x equals -6/10. They gave us all the information, yes? Right here, they give us the point. They give us the slope. So f of x is approximately equal to the linear approximation, which is
-2 parentheses x plus 0.6 ending parentheses -51.
okay. Now they ask us to use this line to approximate the value of f of -5/10. We know what we're doing there, right? So the L of -5/10.
So it's going to be a -51.2.
Okay. -5/10 plus 6/10 is 1/10. Times -2 is -2/10 minus 51. It's -51.2. So the linear approximation, so using the tangent line, at -5/10 is -51.2. Is this approximation greater or less than the actual value of -5/10 and give a reason?
Because it's going to be a less than because it's concave up on that interval. You can't have a tangent line that would intersect twice. So
Okay, so yeah, the key is, maybe I shouldn't have mentioned this earlier, but concave up. If it's concave up, my tangent line has to lie below. And so my approximation is less than the actual value. Okay? Since f of x is concave up on the interval, the tangent line lies below the curve. So the approximation is less than the actual value. Okay, start reading the next one without me. So I know you guys write like a teeny portion of what I write, so.
So here, less than f of x is concave up at x equals negative 0.5. It must be.
You would write more on a real FRQ, yes?
FRQ, yeah.
For
I
your
mean, make it a
response
complete sentence, but I don't know what else I would necessarily
Okay.
write.
Okay, write the linear approximation for f of x at x equals negative 1. Find the approximation for r at negative 1.2. Calculate the error of approximation. Curiosity. Do we need to do this one, or is it seeming repetitive?
Derivative would be kind of annoying. But
I mean, that's the only thing I could see is that the derivative. For practice, if f of x is 1 over x minus 1, how do we do that derivative?
Actually, just x minus 1 to the negative first,
Right? Good review.
which, so that becomes the derivative of it would become negative, then parenthesis x minus 1 to negative second, and then it'd be times 1.
well, which
Right. Yeah.
so then it just becomes
Officially, chain rule says multiply by the derivative of x minus 1, which,
so it just becomes negative 1 over x minus 1 quantity squared.
okay. I just feel like that was good derivative review, yes?
Yeah.
And maybe you guys are saying, that was easy peasy, but we've made some careless mistakes lately, so. Okay. Can I say you guys would have confidence to write your line and
Yeah.
I can move on to 9, I think?
Yeah.
I think I'd rather talk about 9. I feel like 8's gotten repetitive. Okay, given the implicit curve, x squared plus natural log of x over y equals 1. This is why I wanted to move on. Write the linear approximation of this tangent line. This one is repetitive. However, the whole implicitly defined piece, we have to do the derivative of that, and that's not something we're going to solve for y. So, implicit differentiation. Now, there's two different ways we can do this. I'm going to recommend, and I don't know if you guys have been doing this, before we do the derivative of that and get horribly messy, natural log rules, or log rules in general. How can natural log of x over y be split up? Not thinking derivatives, just Algebra 2, pre-calc, log rules. A log,
X over 1 times 1 over, or, yeah, x over 1 times 1 over y.
no. A log that has division inside of it can be broken into two logs that are being subtracted. So natural log of x over y could be rewritten as natural log of x minus natural log of y. Now, am I saying you have to do that? No. But here's the deal. If you don't do that, here's the deal. If you don't do that, you're doing the derivative of natural log of x over y. So 1 over x over y, and then times the quotient rule on top of that, which gets real messy real quick. So, now let's take the derivative. Derivative of x squared is
2x,
Derivative of natural log of x
1 over x,
minus derivative of natural log of y,
1 over y dy dx.
right? So it's 1 over y, tag on the dy dx, equals 0.
So dy dx.
So now we've got to solve all this stuff.
So it's going to be negative 2x minus 1 over x, I'll fix it here in a second, divided by negative 1 over y.
So I'm going to take 2 steps to get there just so I can tweak something that I prefer here. Yes, subtract over the 2x. Actually, no, what we should have done is we should have added over the 1 over y dy dx. Regrets.
Why?
They make everybody positive. Okay, so in retrospect, I would have added over the 1 over y dy dx. Now, Logan, you talked about dividing by 1 over y. Instead of dividing by 1 over y, let's multiply it by y. Officially, we're multiplying by negative y. And that will clean up a little bit better. So now I'm going to have
Negative 2xy. So it's going to be 2xy plus y over x.
that could work. You guys okay with that? Okay. That is our derivative. Now, we need to know slope and a point, yes? How are we going to find the slope? We're evaluating at what?
X equals 1.
And what do we know about the other half of x equals 1? If you look at the provided graph, it is also 1. So we're evaluating at the point 1, 1.
So it's going to be 3.
Mm-hmm.
So L of x equals 3, parentheses x minus 1 plus 1. Any parentheses plus 1.
Mm-hmm. Okay. Okay, B. Using the tangent line to the curve at x equals 1, find the number k such that the point 1.25 comma k is on the curve.
Calculator.
Okay. So when we're finding that k, we're finding the, all we're doing is finding the y value here. So we're finding L of 1.25. Okay? Because that's going to give us our k value. So 3 times 1.25 minus 1 plus 1.
3 times 0.25 would just be 3 fourths plus 1, so 7 fourths.
My brain said 1.75. Only because they gave us the decimal 1.25. K is just a y value. That L of 1.25 is a y value. It's a tricky worded question, but it wasn't anything difficult. Okay, we're just plugging in like we have been.
The error of approximation, is that talking about 1 or 1.25?
1.25 is what I have it in my notes.
How do you determine that on a test or homework?
Hopefully it would be more specific. Well, on A, we never found, we wrote the equation for 1. We wrote the equation for 1. We can't find the error at 1 because this equation is written for exactly 1. The only value we've used it for is 1.25. Okay, so this is the absolute value of actual minus the linear approximation. So f of 1.25 minus L of 1.25 is, according to my notes, 0.44381.
What equation would you use for that? The top one for F
Yes.
on your count. But you don't have a y in that, so how do you put that in the calculator?
So now I know why I had it here. I have it solved as an explicit form. And now I know why I have that off to the side. Because I have it, we solved it at one point, and y equals e to the x squared plus natural log of x minus 1.
I don't even know how one gets that.
Something we need to review.
Mm-hmm.
That's not happening right now, of course, but
Yeah.
I mean, it is something that's doable. And I think if I went through the steps, it would come back to you guys. I really do. Okay?
I'm really wondering how people get 5s on this.
Huh?
I'm really wondering how people get 5 on this AP test.
It's tough. It's really tough. Okay. Now, I will say,
Five in this file.
one thing, they didn't ask this, but I have this written in my notes because there was a percent of error formula that we never talked about, but they gave you in the example, okay? Or in the original. So if they ask you for percent of error in homework, then
Oh, we
that-
got percent of error.
you got percent of error.
We do it in science all the time.
Okay.
Any science.
So, and I agree, you probably do know the basic of percent of error. There's also the formula back there.
It's
Okay.
yours minus the literature value over the literature value times 100.
So, okay, guys. Homework
The worth literature value.
4.5 for tomorrow.
The
Yours
actual,
minus
the
theirs.
actual value.
Yeah, yours minus theirs.